Welcome, folks, to August, the August Meetup. I think it's August 28th, 29th. Anyone on 29th? All right, thanks for verifying that. All right, cool. So if you are hiring and you're not in this room right now and you want to let us know about your job, go to the nyhackr Slack. It's nyhackr.slack.com, or if you need to find it, you can go to nyhackr.org. And in that Slack, there is a channel called Job Postings. Post your job there, and people will apply for your job if it's a cool job. All right? People have gotten jobs throughout the years here. We've gotten many people jobs, usually because they're offering it right in the room. But things are different. Years are different nowadays. But if you want to hire someone, put it there. Now, for everyone in the room, the pizza today was from Artistic Pizza. So regulars know what to do. New folks, pull out your phones and go to bit.ly/pizzapoll, all lowercase. Go there. I want to see everyone. If you ate a slice of pizza, pull out your phones. This is mandatory voting. And I want you to go rate the pizza on, there's a 1 to 5 scale. Let us know what the pizza is. For those of you who are not regulars here, we've been collecting this pizza poll data for about 12 years or so. And if you go to nyhackr.org and click on more, you'll see there's a live JavaScript bar chart of the pizza data. So we are really proud of this. So go there and vote on the pizza and let us know how it is. Every month we do a different place, but of course we do some repeats, so it's longitudinal. And this way we can always see how good the pizza is. So thank you everyone for voting. And for those of you at home who are not eating amazing New York City pizza, let us know what you're eating. You can chat either right there in the YouTube comments, or you can chat at nyhackr. There's a channel called Monthly Meetup Chat. Go there and let us know what you're eating. If you're in the city and you couldn't make it down here, hopefully you got pizza there. Or if you're somewhere else, let us know what you're eating. All right, anything's cool, just let us know. You can tell at this meetup, food's a big deal, or at least pizza's a big deal. So if you're eating food that's not pizza, tell us, but feel a little shame about yourself, okay? All right, next month, on September 24th will be the meetup. Nikki's talking about operating budget data. September 24th, that will be announced in the next few days. We're really excited to have the MTA come give a talk about this. Everyone be nice. They're the good ones at the MTA making things work, right? Yes. So thank you for giving that talk. September 24th, both in person here at NYU, in a bigger room, so no pressure, all right? More people are going to come. And virtually as well. All right, so September 24th, remember that, getting a great talk about MTA data. So if you have all your questions about the subway, now's the time to ask. You're an expert in the 100-year-old switching system, right? Of course. Perfect. So you have questions about the electrical signals, you know who to ask now. Then October 15th, we're going to have an election-focused meetup. Yeah. If someone doesn't lose their job, it didn't go right. All right? I expect something to go horribly wrong for one of the speakers. We're going to have a few speakers partnered to Shobik and his organization. The acronym is NYAPOR. NYAPOR, thank you. I can never get that acronym right. We're going to work with NYAPOR, which is? New York chapter of the American Association for Public Opinion Research. It's a public opinion meetup group, sir. Right? But it's going to be about polling and elections, mostly focused on this election, but there'll be some historical stuff too. Details will come out in September after the next meetup. That should be a lot of fun, right in time for the election. Right? Everyone does this. 8 years ago, we had an election theme meetup because that's the last election we were here in person for. So it's always fun to do that because there are a lot of good political science and election people who are members of this meetup group. So thank you for helping us arrange that show book. Then also in October 28th through 30th, we have the R in Government Conference. That's the 28th through 30th at Georgetown in DC. It's a whole conference about R and friends. So there's Python, SQL, Go, Julia, just some straight up math and project management stuff. That's going to happen at Georgetown. And the website is rstats.ai/gov, G-O-V. Or just go to rstats.ai and you can find it. For those of you that have been to the New York R Conference, it's similar with less alcohol, because it's at a university, but similar idea, but more government public sector focus. We're talking federal, defense, local, state, city, that's local, I guess, and even sometimes we have international governments. Also NGOs, so it's just generally public sector and government. If you're a member of this group, which you all are, you can use code NYHackR for a 20% discount. And if you're a federal employee, you could use code GovM25, all caps, GovM25, for a 25% discount off the government ticket until September 15th. GOVEM 25, government employee 25, off the government ticket until September 15th. All right, so if you're a government employee, and that works for both in-person and virtual, you can use those codes. So again, rstats.ai/gov. The conference is October 28th through 30th. Lastly, we are going to go to the bar after the talk. So if you don't drink alcohol, that's fine. Just come and hang out. Have a soda, have a juice, have a water. Just come chat with us. The bar is to be determined because we have 2 regular bars and we can't get a consensus where we're going yet. By the time the talk is over, we will pick a bar. It'll be none of those 2. We're going to pick a different bar now. Try something different. It's going to be Vol de Nys, probably. That's a Belgian beer bar. Just throw that out there. I might pick that. Anyway, we're going to go to the bar. So if you're watching from New York City or the area, and even come to the meetup, people have done this. Come to the bar afterwards. If you're in the room, come to the bar. If you can't make it, maybe next time. But again, you don't have to drink. Just come hang out and have fun chatting with us. All right? During the talk or after the talk, if you have questions, if you're in the room, it's very easy to raise your hand and ask a question. If you're virtual and you want to ask a question, you have 2 options. Either use the YouTube chats and ask a question there, or use the monthly meetup chat in the Slack, ask the question there, and I will collate the questions and ask them of the speaker. All right? So in the room, easy. If you're virtual, just ask virtually, and we will relay your question for you. All right. With that, I hope everyone remembered to vote on the pizza. Remember, the next 2 meetups are September 24th, October 15th. We have the conference October 20th through 30th. If you have a job, you're going to post it in the jobs channel. And if you want to, you're going to come to the bar afterwards. Everyone cool? All right. So our speaker this month is the head of Our Ladies NYC. Very excited to have her here. Everyone, please welcome Dorota.
Thank you. All right. Hi, everybody. Thanks for coming today. I'm going to be talking about the Janitor Package and how it can help you clean your data. So a little bit about me. I have full screen. Okay, perfect. I have experience with data cleaning analysis and visualization, primarily in the higher education space, so mostly data on community colleges and universities. I have a master's in applied statistics and from NYU, actually, so it's really nice to be back here. And I'm proficient in R, SAS, and SQL. And I've worked in academia, nonprofits, and the private sector, currently working at a small consulting firm that primarily focuses on developing tools that help service members, so military folks, go to college. And I have 2 lovely Boston Terriers, Beckett and Charlotte. Just wanted to throw them in there because pictures of cute animals make any presentation better. All right, a little bit about this talk before we jump into things. So this talk will be a high-level overview of some helpful functions from the Janitor Package, and we're also going to be discussing some data cleaning issues that you'll commonly encounter as you're working with messy data. And then I'll work through those data cleaning issues with some real data. This talk will not be an in-depth tutorial on R programming or the tidyverse, and it will not be a comprehensive review of every single janitor function. There's a lot in there. I'm going to give you the best ones. And I'll be using data from 2 public sources, the Integrated Post-Secondary Education Data System, otherwise known as IPEDS, and the College Scorecard. College Scorecard actually uses some IPEDS data to build its institutional profiles, but it also uses data from other sources, primarily data on student debt repayment and earnings. So that's the data I'm most interested in. At the bottom here, I put links to the data source websites and how I got my data files. All right. Now that we're done with logistics, let's get into it. So I'm going to go a little bit over the package itself, and then I'm going to talk about these common data cleaning issues. And again, I'm going to demonstrate how to fix them or deal with them. So we're going to talk about issues with column names and column types, date formats, empty fields, missing values, duplicates, and then at the end, I'm going to talk a little bit about making tables because that is a part of your data cleaning journey. All right, about the Janitor Package. Some key features. So first and foremost, most people probably know the Janitor Package for its very helpful function that helps you clean column names. And it cleans them so that they all have a consistent format. And this is really important because R is case sensitive, and if your column names are sometimes capitalized, sometimes not, and that's something you have to think about, that's just a waste of your brain power. Next, the package makes it really easy to explore duplicate records, which isn't too hard to do manually, but it just makes it easier, saves you lines of code. It provides very quick frequency tables or cross tabulations, and it has functions that help you format those tables. And lastly, a nice feature of the Janitor package is that it works really well with the tidyverse and the pipe function. So it's really easy to integrate into your workflow. At the bottom here, I put a link to the detailed package documentation that lists all their functions and a nice high-level vignette for you that covers most of what I'm going to be talking about today, plus some additional functions that you may want to look into. All right, the common data cleaning issues that you'll encounter. First and foremost is column names. And again, this is probably the thing that Janitor is most well known for. It is the single function that I use most from this package. But the column name issues that you're going to encounter are different capitalizations or uses of different capital letters throughout, inconsistent delimiters between words. Some will use underscores, some periods, some other symbols. Some column names will include the symbols for percent or number as opposed to writing out the word explicitly, which really isn't a huge issue, but it can be a bit ambiguous, so it's better to be explicit and consistent. And the solution from the Janitor package for this is the clean names function. So here's a little demonstration, right? I have this 9-column data frame here, and I have these very messy column names. The first 3 columns have some IDs in them. The 4th column has a bunch of special characters. The 5th one has a percent symbol in parentheses. And then there's 2 columns that have the same name and then 2 empty columns. And all you have to do is just feed your data frame into the clean names function. And I'm not setting any special arguments here. I'm using all the defaults, and it'll clean these column names for me. And here's the results, right? On the left are my original messy columns. On the right are the nice cleaned up columns. So now everything is lowercase, no special characters, no symbols or parentheses. The column names that have the same value are now numerated, so there's no duplicate column names. The only issue here, if you'll notice, that second column called second ID, the ID did not get delimited with an underscore, and that's because it wasn't originally delimited in the first version, right? There was no capitalization to indicate that the word ID is a separate word. So that's the one little issue that I've come across that clean names doesn't handle very well, so you'll probably have to deal with that more manually. Clean names gives you the option of using a bunch of different cases. The default is the snake case, but you have a lot to choose from, so you can use whatever your heart desires. And a little bit more about this function. So the Janitor package also has a make clean names function, which is a little more usable, more generally usable, because it can work on a vector, not just a data frame. Clean names only works on data frames. And then the clean names function under the hood uses a function called toAnyCase from the snake case package. And the reason I'm mentioning that is because that function provides a couple of arguments that might be useful. There's an abbreviations argument, so you can tell it a specific abbreviation or a vector of abbreviations that you want to leave untouched. However, the caveat with this argument is that it only works with a few of the cases. And the abbreviations, again, need to be delimited originally in some way. So if we look at our first 3 columns, first ID, second ID, third ID, and then I'm applying clean names with the upper camel case, and I'm setting the abbreviation equal to ID, it keeps the word ID all caps in the first and third columns, but not the second column because it wasn't delimited originally. The next argument is sep out. So this allows you to specify a different separator besides an underscore. So for you period lovers, go ahead and use this one. And then empty fill will, you will specify a string for this argument, and that string will replace the empty column names. The caveat with this one is that the string will repeat for all the empty columns, so you need to provide multiple strings. And then this also doesn't work on data frames. It'll mostly just work on vectors of column names. A little demo. So here I'm importing my college scorecard data, and I'm only selecting the first 20 columns. And then I'm applying the clean names function and just showing you the difference here. On the surface, this doesn't look like much has changed, right? It went from uppercase to lowercase, and it looks like the college scorecard data was already using underscores in some cases. So not a huge change, but this file has over 3,300 columns. So by using the clean names function, I am guaranteed that all of my 3,300 columns are formatted exactly the same way. And that is just such a time saver. I do this on every single file that I import, even if I know the column names are probably fine. All right, the next issue that you'll encounter, right, is column types. So different column types can be an issue if you're trying to combine your data in some way. specifically for functions like dplyr's bind rows function or baser's bind function, which will append your two files. If there are different column types, your append will fail. So the solution to this is the compare df_cols function from the Janitor package. So what this function does is it returns a nice clean summary of how your data frames compare in terms of column names and column types. So here's an example. I created two small data frames. Data frame 1 has 2 columns, data frame 2 has 3 columns, and then I just run those two data frames in the compare df_cols function. And at the bottom there you see a table. The first column gives me all the column names, and then the next columns summarize the types for each data frame. So from this, I can see that column A exists in both data frames and it's integer, so that one's fine. Column B also exists in both data frames, but it's a different data type. So one is character, one is a factor. That's going to be an issue, and you're going to have to fix that before you try to append these files. The last column, column C, only exists in data frame 2, which won't be an issue for the dplyr bind rows function, but it will be an issue for rbind. So you'll need to pay attention to that, depending on what you're using. But it just gives you a nice summary. You can include as many data frames as you want in this function, or a list of data frames. Yes?
Do we ask a question?
Yeah, go ahead.
Why was one character, why is column B, why is one character, one is factor?
That's just how it was in the two data frames.
Oh, it's, okay.
Yeah.
That's just, well, okay.
Yeah, I just said it that way to demonstrate.
Repeat the question.
Oh, sorry. The question was, why was one column character, one was factor?
I'm looking at that as an input format.
Yeah.
I don't see it.
Oh, yeah. Sorry, the text got shifted over. There's a strings as factors equals true argument there.
Okay.
Yeah. So, yeah. Yeah. All right, so a little demo with my real world data. So my college scorecard data is at the top there. I'm piping that into the clean names function to clean my column names. And I'm just selecting a couple of columns I'm interested in. For the iPads data, I'm importing that file. I've already pre-selected the columns I care about when I downloaded the file. So I'm just piping that into clean names. And I'm going to rename a couple of columns because they're obnoxiously long. But otherwise, I'm just importing data, selecting columns I care about. And then I feed those two data frames, my CS and my iPads, into compare df_cols. And I get a nice little summary of all my columns. And from this output, I can see that none of the columns exist in both data frames, which is going to be an issue when I'm trying to combine these files. Specifically, if you look at rows 7 and 8, unit ID should be a match. That should be the same column. But because one of the data sets used an underscore and the other one didn't, those aren't going to show up as the same column. So I'm going to have to fix that before I try to combine these two data frames. And I'm also noticing there's one column at the bottom there that's illogical, and I don't actually know what that column is, so we'll have to do some digging into that. All right, so date issues. So dates are probably my favorite thing to clean, but also the most frustrating thing to clean because so many things can happen with data that is just unbelievable. So your dates could import as numbers. They don't look like dates, they just look like a sequence of numbers, and those numbers might mean different things, and they might mean different things because it'll depend on where your data came from. If the date was created in Excel or SAS, those numbers are going to represent different dates, right? Because Excel and SAS will calculate the number of seconds, minutes, or days from an origin date, and those origin dates are different. So you're going to have to be very careful if your dates are represented as numbers. Now let's say you do have an actual column of dates that look like dates. You can still have a mix of formats in that column, right? You can have, depending on if you're in the US or not, the months and the days might be switched. The months might be written out as a word or an abbreviated word. The years might be different lengths, different number of digits. And the dates might use different delimiters or no delimiters at all. So it can just be a whole mix of things. And date columns can also contain a mix of things that look like dates and things that look like just numbers. So it's your job to figure out which one is right and how to format them. So the solution here actually, I'm going to caveat this, right? I don't actually use the Janitor package to clean dates. Because they are so messy, I usually do them a little more manually, and I tend to rely on the Lubridate package a lot because it's a great package for dates. However, I would be remiss if I didn't tell you about a couple of these functions that exist in the Janitor package. So the first set of functions I want to talk about is the numeric to date function. So these are functions that can help you convert Excel or SAS numbers to actual date values. There's also some manual conversions you can do between the two, which I've listed here. It's just basic subtraction and multiplication, though the date time conversion won't always work correctly. So here I'm taking the number 41103 and converting it to a date using the Excel numeric to date function. You can turn that into a date time pretty simply, right? If there's a decimal point following that whole number, you just have to specify the argument include time equals true, and you'll get a date time instead of a date. For SAS, it's very similar. Here in this example, I'm using those Excel numbers and converting them to SAS numbers. So it works fine for the date, right? We get 41103 minus 2196 gives me that SAS number, and that gets converted to July 13th, 2012, just like the Excel numeric to date function. The date time, though, doesn't get converted correctly. If you'll notice, it's actually July 12, 2012, so it's off by 20 hours. So I just manually subtracted 20 hours in seconds from my conversion, and then I got the right date. So again, just a caveat that date times can be tricky. The other set of Janitor functions that are good for dates are the convert to date and convert to date time function. The convert to date function does exactly what you'd expect, right? It takes a vector of both date looking values and number values. These are Excel numbers specifically, not SAS, and will convert all of those to a date. Very easy. The convert to date time function is a little trickier. You have to specify additional arguments for this one, the time zone, the character function, and then this truncated argument, even though these already have defaults in the function in the documentation. And you can see that the character function is using lubridate anyway. So again, my advice would just be to use lubridate directly. And I also want to mention that I'm not actually sure what the truncated argument is for. It's not well documented in their package documentation, but it is related to whatever character function you specify. All right, I don't actually have a demo with my real data here because I don't have any date columns in my college scorecard or iPads data. So we're going to move on just for the sake of time. Empty fields. So sometimes you're going to get columns or rows that are totally empty, or columns that have all the same values. So it's like a constant column. And those things may or may not be useful to you. In most cases, they're probably not useful, and you're going to end up dropping them. Here's a data frame, just for a quick example, right? 4 columns, A, B, C, D. Column 1 is going to be the number 1 for every single record. B and D are going to be a mix of numbers and missings, and C is going to be all missings. The solution from the Janitor package for this is 2 functions. The remove constant function will, as it says, remove any columns that are completely constant, that have the same value for all rows. In this case, it removed column A and column C, because column A was all ones, column C was all missings. Then there's the remove empty function, which allows you to remove either empty rows or empty columns if you specify the which argument. Here, I'm doing columns, and this removes column C because C was totally empty. Now, if I do this for rows, it's actually not going to drop anything for me because column A still exists in my data frame, and that's preventing row 2 from being totally empty. So I'm going to run the remove constant first and then remove empty. And now I've gotten rid of columns A and C and row 2. So again, I mean, you could do this right with select in dplyr and just drop the columns that you know are empty. But this way, you don't have to specify any column names. It'll do it all automatically for you. A little demo with my real data here. So in my iPads data set, here I'm just taking a quick look at the first 6 rows. And from the first 6 rows, I don't see any empty rows, and they're not likely to be empty because I'm pretty sure that unit ID at the very least exists for every case. However, it looks like the bachelor's column or that last column might be totally empty. So I'm going to go ahead and try the remove empty function on the columns. And if I do that, that very last column gets dropped, right, X5. And again, I don't know what that column is. It's not in the documentation, so I'm guessing it just got added as a column when I imported my file. So I'm totally fine with dropping it. Let's drop it and move on. Missing values. So missing values, right, they're treated as NAs when they're imported correctly into R, but they can also be imported as any number of things. It could be the letters NA treated as a character, n/A in whatever form that comes in. It could be a period, it could be weird negative numbers, it could literally be anything. So for this, actually, Janitor used to have a function, but now it just recommends you use the dplyr NAIF function. So I'm going to demonstrate that real quick. So here I'm taking the Star Wars data set, and this data set has a couple of different columns, but one of them is eye color. So it lists different eye colors, and one of those values is unknown. And I want to treat that as a missing, as an NA. So I'm just going to mutate my eye color column and use the NAIF function to set that unknown value to be NA. And when I do that, on the left, you can see at the bottom of that table, unknown is still there, but after I do that, it's now an NA. And it's really easy to apply this function across multiple columns, right? I can use a combination of mutate and across. In that top example, I'm doing this across all my character columns. And in the bottom example, I'm doing it specifically across columns that contain the word color in the column name. So eye color, I believe there's also skin color and hair color. The only downside that I've experienced with this function is that it doesn't really work with multiple values. If you're trying to replace multiple values to be NA, it doesn't work well with NAIF, because what NAIF does is it recycles that string that you give it for however many rows you have in your column. And if you give it more than one string and it doesn't line up exactly with the number of rows after it recycles it, it's going to throw you an error. So if you want to do multiple values be replaced with NA, I would suggest you use something like gsub or the string R package, which has str replace functions that work really well with multiple values. You just have to explicitly specify the NA in those cases. And I don't have a demo with my real data because I don't have any funky NA values. They all imported correctly. Gosh darn, that public data is so good. All right, duplicates. So duplicates can be a little tricky. You kind of have to do a little detective work with duplicates and figure out why they're in your data and how to resolve them, right? Which records do you actually want to keep out of those duplicates? And there's three main types of duplicates that I've encountered. So there's complete duplicates, which are really easy, right? You have rows that are completely identical. In that case, you just drop whichever ones and keep one. There's partial duplicates, which are mostly identical, but they might have some different values across a couple of different columns. And then there's blank duplicates, which are, again, mostly identical, but one or more rows have some missing values in a couple of columns. So blank duplicates are also pretty easy to resolve, right? You just keep the more complete records. The partial duplicates is where you're going to have to do some detective work. So Janitor can help you out with that detective work with the getDupes function. So what this does is it will, you supply whatever columns you want to look for duplicates across, and it will return all the records in your data frame that are duplicates on those columns. So here's an example with the empty cars data set. Here, what I'm doing is I'm actually saying to look for duplicates across all the columns except WT and QSEC. And then what it does is it spits out, again, just two rows in my data frame this time, but it gives me all the columns first that it checked for duplicates across. It adds a count of the duplicates. So in this case, there's only 2. And then at the end, it gives me those leftover columns that have different values. So these would be partial duplicates. And I would have to decide if I want to keep them in my data because they're actually meaningfully different, or if I can trust one duplicate more over the other. The more manual way to do this in dplyr would be to group by the columns that you want to check for duplicates across, create a manual count of the number of records, and then filter based on that count. So here I was able to get the same output, but I needed 4 lines of code instead of 1. So it's a little bit easier, and I didn't have to specify all those column names explicitly. A demo with my real data here. So for my iPad's data and for my color scorecard data, I want to combine those two using the unit ID columns. So I want to make sure those are unique, and they are unique. But in my iPad's data, if I look for duplicates on institution name, a lot of them come up. There's 191 rows in this output. And the largest group of duplicates has 6 records. So there's 6 records with the same institution name, The unit ID is unique. All the other values seem to be different. So in this case, just knowing what I know about these data sources, I'm not going to worry too much about these duplicates. I do trust my unit ID column to be unique. The reason these duplicates are probably happening is because there just happen to be 6 institutions with the same name across the US. And sure enough, if I spot check these unit IDs on the IPEDS database, you'll find that these 6 institutes are in different locations. The other thing that might happen with institution name is that one institution may have satellite locations or campuses, and those might be assigned the main campus name in the database. So that's the other reason for those duplicates. And again, since I understand why these duplicates are happening and I trust my unique identifier, I'm not going to worry about dropping these. All right, the last few things I want to talk about here are frequency tables. So again, tables and cross-tabulations, frequency tables, not directly related to data cleaning, but they should be part of your process. You should be checking your variables, counting them, and looking at all the different values, particularly with your date columns. And dplyr has a nice function that, Janitor has a nice function that helps you do that. So the table function is actually a tidyverse-oriented replacement for the base R table function. It is able to count combinations of 1, 2, or 3 variables. And here's an example. On the left, we have base R, right? It takes in 2 vectors, not a data frame. And it outputs, I believe, a matrix, not a data frame. The janitor table function is able to accept a data frame, and it outputs a data frame, and it includes at least one name of your columns in the output, which is nice. It's still not super clear if that's for the rows or columns, so if you're not familiar with R, you might not understand. It is for the rows. And what's nice about this is there's a specific vignette for the table function that gives you a ton of more examples and information about why it's useful. So I recommend checking that out. Again, I don't have good categorical variables in my data, so I'm not going to give you a demo. But I'm going to use the Star Wars data instead. And I'm going to table just one column for this example. And you'll notice that not only does it give you a count, but it also automatically calculates the percentage for you. And I just sorted my data by percentage to figure out the most common occurring eye colors. So it's really nice. It already gives you a little leg up over just the count function. It gives you the percentage automatically. So the other thing about the table function is it works really well with these other functions from the Janitor package that help you format your tables. That said, you can use those functions on tables that you created yourself manually. So those functions are the adorn functions. They improve your tables by making them way more informative and more readable. Specifically, you can automatically calculate totals or percentages, both row-wise and column-wise. You can format your percentages by doing different types of rounding up or down, displaying a specific number of digits, and even including the percent sign, which can be useful for readability. And if you do calculate percentages, you can then add back in those underlying counts, those ends. So you can have both percentages and ends. And lastly, you can add the names for both your variables in your crosstabs, so it's really clear which variables on the rows, which variables on the columns. Here's a little demo. So for the Star Wars data, I'm going to specifically look at the human species, and then I'm going to exclude the none skin color. And then I'm just going to table eye color against skin color. And so here you get, again, very simple table, just raw counts, nothing too fancy. Then I'm going to adorn totals. And you can adorn, again, totals row-wise or column-wise, or both. So I'm doing both here. So you can see that at the bottom of my table, I have a totals row, and at the far right of my table, I have a totals column. If I then adorn percentages on top of that, and I'm going to do row-wise percentages specifically, I get this ugly thing. So these percentages are not formatted automatically, and it's just hard to look at. So I'm going to spare you. Instead, I'm going to adorn percent formatting on top of that, and I'm going to set digits equal to 0, and I'm going to make sure that my percent sign is included. So now instead of counts, you have percentages, row-wise percentages. But I liked my counts. I want to add those back in. So you just do adorn ends, and now you have your counts in the parentheses next to your percentages. And lastly, if I want to add in that second column name or, for skin color, you just adorn the title. So here you go. You got this really nice table, tells you a lot of information, a lot of numbers and math happening, and I didn't have to calculate a single thing. If I want to do something like this with my data. So here I'm taking my college scorecard data. I'm going to combine my college scorecard and iPads data, right? I'm taking college scorecard. I'm going to rename that unit ID column that I identified as an issue earlier. I'm going to do a full join with my iPads data using that ID column. And then I'm going to pivot my data a little bit so that I have graduation rates in one column and the type of degree in one column. So with that, I'm going to create my own little table here. I'm going to group by degree type. I'm going to do a count. I'm going to do an average graduation rate, and I'm going to calculate average median earnings, 5 years post-graduation. You'll notice that I'm also dividing the graduation rate by 100, and that's because I want to use the adorn % formatting function, and that's going to work on decimal representations of percentages, not the whole number versions, because it automatically multiplies by 100 for you. So then once I have my little table, I'm going to feed in the adorn % formatting function. And I want to be careful here because adorn % formatting will automatically apply the formatting to all numeric columns, but I don't want that. I don't want my median earnings displayed as a percentage. So I want to specify specifically that I want the graduation rate column to be displayed as a percentage, but the only way to do that is if you explicitly define all of the previous arguments. So I have to say digits equal 0, I have to tell it the type of rounding I want to do, and I want to affix my % sign. And once I have those arguments explicitly specified, then I can use a helper function to pick out the column that I want to format. And so my table now has my average grad rate is displaying as a nice little percentage, and everything else looks the same. I have not found that Janitor is good for formatting currency. There might be a better package for that. So that's the one downside here, but it's good for percentages. And then just to bring it home, here's my data set. I just did a little visualization. There's nothing to do with Janitor, but you can see that there might be some sort of linear relationship between higher graduation rates and higher median earnings 5 years post-graduation, specifically for those earning a bachelor's as opposed to a certificate. And that's it. Any questions, reactions, thoughts, feelings? Yes.
Are there any limitations in terms of data volume?
Are there any limitations in terms of data volume? No, I haven't. The functions that I'd mentioned here work super fast. And I haven't worked with data that's in the billions, right? I've worked with data that's in the hundreds of thousands in terms of rows and multiple thousands of columns, and that works pretty fast still. So I don't think so. Good question.
What about, does it work on like tables that are like database-based tables? It doesn't work on all, dplyr allows other backends, like a data deal backend or Postgres or .db. Does it work on those?
No, I think it works mostly on data frames, and it works on tables and data frames, but if you're connected to a database through R, you're going to probably load that as a table into your environment first.
No, like the, I assume that's what they're asking. It's, my mic, so I'll say that.
All right. So dplyr has like dbplyr.
Yes.
What dbplyr tables? Oh, it would pull it in first.
Right.
Okay. All right.
Yeah.
Cool.
Good question.
And let's have a question before I go to another virtual one. All right. After you do the adorn functions, is it still a tibble or is it like a different type of object?
No, good question. Yeah, it's still a tibble. Yeah.
How does it do the title thing?
I don't know.
Okay.
Yeah, I think I have that question too, like, when it's putting the ends in parentheses, is that like a separate column in the table, or is it?
Good question.
I'm
guessing it turns them into character string. Maybe the adorn % formatting does change it to a different type.
Yeah, there's no column types
Yeah, none of the output ever has column types.
Oh, okay.
Honestly, that last row is the totals column. That's going to be, it wouldn't make sense for it to be columns.
Right. I mean, I know that when I use adorn totals or adorn percentages, it still remains a tibble, and I can continue working with it. But when you do the percent formatting, it might change things, or they might all become character columns. That's my only guess. Yeah. Yes.
Just a follow-up to that. So, Janitor makes its own class, which is a tablet, which is what's online.
Right.
While, which is a class on top of Tibble.
Okay.
So it's a Tibble, but for things like this, it has its own print method, right? So that way it doesn't show like the Tibbles of like types and stuff for the summary, but it's a Tibble in terms of like Tibble functions still, methods still operate on it as a Tibble. It's a class Tabble, Tibble.
So it's over like a print method on too, basically.
Yeah.
For people virtually, I think they could probably hear it at the mic, probably. Basically, it's its own type on top of Tibbles and has its own print method, in case no one heard.
Thanks for sharing that. Yeah, like I said, I mostly use these directly on Tibbles. I don't use the table function that often, so thank you. Yes?
Is the package still like being actively managed, and is there any new functionalities that are being planned to come on?
Is the package still being actively managed, and are there any new functionalities? I don't think an update has been published in a few years, so I'm not sure. I hope it is. If anyone has suggestions, you can always post on their GitHub issues, right?
Who maintains it? Do you know?
No, I don't know.
Is it our open side? Anyone know? Is it?
No, it's not. It's not. It's not our open side though. I think it's Sam Burke, who's a member of ours, who runs it. And I've seen stuff as late as last year that's
great.
been updated with it. You know, that particular thing that I knew because I was just in some of the issues with him back and forth with the dplyr team about that method. So he's still active.
Great. Okay, so it is actively maintained. Awesome.
Most recent release was 2 years ago.
Most recent release was 3 years ago. That's what I was thinking of. Yeah.
All right. Any last chance? We have a chance to we have time for like two more if anyone has a question, but.
You could also
All right.
ask questions about working with higher ed data. It doesn't have to be janitor specific.
All right, then if you have more questions, you come to the bar.
No, I don't think so.
As we
Sorry.
break down the room, they can ask you questions. If anyone wants to ask a question while we're breaking down the room, they
Yes,
can
I'll
talk to
be
you
here
then.
for like 20 more minutes, 15 more minutes.
All right,
Yeah.
cool. Then thank you very much for this talk.
Thank you.
All right, folks, thank you for attending. Just a quick recap of the earlier announcements. Next month, September 24th, we have Nikki back there who's already trying to escape, talking about MTA data. All right, so it's going to be a great talk. Then October 15th, we have Shobik and my Arpoor, roughly, I said that correctly? Close, talking about election day, the upcoming election, November, right? November, no one knows the date? 5th? Has to be the first Tuesday, so let's go with that. All right. So it has to be the Tuesday after the first Monday, but let's just go with that. All right, so November 5th, everyone's going to vote. October 28th through 30th, we have our government conference down in DC. You want to use code nyhackr for 20% off. Go to rstats.ai/gov. Everyone voted on the pizza. If you have a job, you're going to post it in Slack. And we are going to go to a bar. We picked a bar. It was none of the above. We are going to go to Amity Hall. It's on West 3rd Street. I saw a few thumbs up back there. It's Amity Hall on West 3rd or West 4th. Look it up on Google Maps. We'll see you there. Some of us are going to break down the room. We'll send people in waves. I'll join you in a little bit. I'm sure other people here. Paul, you're going to join? Where's Paul? No? Oh, Noam's going to join. I know Noam is. And Shobik's going to join. And whoever else wants to join, you're going to join. Yeah, everyone's going to join. All right. If not, I'll see you next month. And we'll have a great time. Thank you, everyone, for being here. And I'll see you at another meetup.